Hey folks, Paul Abernathy here. Welcome back to the 2023 National Electrical Code Educational Series. Today is going to be a pretty brief one. We're just going to talk about sizing branch circuits to cooking units. Maybe it's an in-wall oven, or maybe it's a cooktop, counter-mounted. So we're going to look at that today and just kind of look at the rules. Keep it short and quick. Of course, if you're in our Fast Tracks program, we go over this in extreme detail. But we want to make sure that we give you a little something. And if you're interested in learning the code a little bit deeper, our program is the one for you. There is nothing like it. So go right there to this website, watch our demo. You can learn a little bit about the National Electrical Code. And of course, the 2023 National Electrical Code has so many changes. So if you're studying for an exam and you're using the 2023, then you want to get into our program. But of course, we have programs for the 2020 edition of the NEC as well as the 2017 edition. So we've got you covered no matter what if you want to get into a really good exam prep program. And if you just want to learn the NEC at a much higher level, then our program is perfect for that because we cover code from the beginning of the code book to the end of the code book, 19 units. And so check out the website, watch the demo. We'd love to have you in the Fast Tracks family. All right, let's get into today and we'll kind of dissect it a little bit in this lesson. So again, we're doing the 2023 edition. And the first thing we'll look at here is today we want to talk about, okay, it may seem simple, but I have got a cooktop and I need to run a branch circuit to it. All right, so if I'm running a branch circuit to that cooktop, how do I size the branch circuit? How do I know what size overcurrent protection I need? And we know that a cooktop is not a continuous load because it's not going to be 100% of its output for 3 hours or more. We have a definition in Article 100 for what continuous loads are. So we know it's not a continuous load. So we need to size the conductors and we need to size the overcurrent protection. Now, when you're doing a single cooktop, you need to locate the nameplate. It'll be on the product. And once you find it, you'll find out what kW is, kilowatts. And that's what we're going to use in our example. Now, I want to walk you through how the National Electrical Code allows you to use various notes under Table 220.55. And that's the table you're probably familiar with for range calculations. Now, generally, 220.55 is under Part 3 of Article 220, and that's for feeders and service calculations. But we're talking branch circuits. So how do we get there? Well, we're going to look at how you get there. You might know that you do use it and you do use those notes, but I like to kind of walk you through the chain of events that allows us to use that table when we're doing branch circuits. Okay, so let's kind of look at our question first, look at the variables, and then we'll dissect it out. So what does it say first? It says branch circuit calculation for one cooktop with a nameplate rating of 6.5 kW at 240 volts. Okay, so 6.5 kW, K is kilo. So we know that we can take 6.5 times 1,000. That's 6,500 watts. Now remember, watts is synonymous, means the same thing as VA for these calculations, okay? All right, so we've had 6,500, which is what you'll see right here. And now the simple thing we're gonna do is take that 6,500 and divide it by the voltage. In our case, the voltage is 240. So we're going to take that 6,500. Make sure you got your calculator when you're working with me in our series here. 6,500 divided by 240. And that gives me what? 27.08, which is going to round it to 27.1. Remember, 0.5 or greater, we're going to round up. So in this case, 27.08, we're going to get it down, and that's going to be 27.1 and get rid of all of the additional numbers after that. So it's 27.1 rounded. Okay, so we have 27.1, and that's what our amps are for, and we'll highlight that. That's what the amps are for this counter-mounted cooking unit. Now, first thing, if you'll notice up here, it gives me permission to use table 220.55 note number 5. Now that's for branch circuits. In the 2020 edition of the National Electrical Code, that was under note 4. But in the 2023, it's now under note 5. And in fact, all of the different pieces of note 4 under the 2020 edition have been broken out now for ease of understanding, and they've been added as additional notes. Okay, and remember, notes in this case are very much in play. We're not talking about informational notes. Anytime you see the word note under tables, that means that they are in play and they are applicable. Okay, so just want you to be aware of that. Now, let's go real quick to the code, and what we're looking for is to see, okay, give me where it tells me that I can use the notes and table 220.55 when I'm doing branch circuits, because 220.55 is actually under part 3 of 220, which is feeders and service. So something's got to get me there. So let's go there and look. All right, so here we are under 220. Again, at the very beginning of here, you see 220. And let me go on and drop it down a little bit for you folks so that you can see this. I want you to be able to see everything here. Okay, so this is what we're looking at right here. Now what we're going to go down to is, all right, we're going down to part 2 because this is a branch circuit calculation, right? We're talking about the branch circuit to a cooktop. So we're in part 2. And we come down and you're going to notice that you have these loads, which is, with the 2023, it kind of brought it out to say, okay, 220.14 is all other loads, all occupancy applications, and it kind of breaks it down. So for us, we're going to go down to 220.14 and right here, B. And this is the one that's dealing with electric dryers as well as cooking appliances for these dwellings, all right? So in our case here, it reminds us that the load calculation shall be permitted as specified in 220.54, which is for the dryers, not what our topic is today. And then it's 220.55 for electric ranges and other cooking equipment. So how do we get permission to use the values in 220.55 in the notes? By the permission in 220.14b. Now remember, we're in the 2023 edition of the National Electrical Code. Yours may be different for the 2020, but it's still going to be in the same area. It gives you that permission. All right. So now, what do we want to do? Well, we're going to go on and go back to the question now that we know that we can use the tables and the notes. Let's go back to our equation again. All right. So we were 27.1 with our rounding, and the question I have for you is, okay, well, do they make an overcurrent protective device that's rated 27.1? And where will we go to find standard size overcurrent devices? You got it. We're going to go to 240.6A1. We're going to go do that now so we can kind of look at the different sizes. We need to see if there's one for 27.1. So we're going to go down here. Give me a second. I'll get us down to where we need to be. And we will be right here. Okay, so here's the table y'all all are probably familiar with. This is standard sizes and ratings for fuses and inverse time circuit breakers. Understand that these are standard types, but they do make other types ratings that are not standard. But anytime the reference in the NEC says standard type, this is where you're going to go. Right? So this is 240.6, right? And you look down, and we needed 27.1. Well, I think if you look down here, you'll see there's 25 right here, and then it jumps to 30, okay? So the thing about it now is that, okay, since they don't make one for 27.1, what do I do? Well, I need to know, can I jump up to 30? All right, well, we're going to follow that. But before I do that, I want to remind you that even though this table has all the standard sizes, I want you to also know that there's some additional fuse sizes right here. Don't forget these. If you're preparing for an exam, highlight that because it's common for them to ask you a certain different fuses or circuit breaker sizes and want to know if it's standard or not. And for example, you might get a question that says, is a 20, a 15, a 75, or a 601, which is not standard? Well, obviously 75, because 601 is listed right here is a standard for a fuse. But down here, you see it's 70, and then it jumps to 80. So 75 is not a standard size. Now, does that mean they don't make one? Well, manufacturers may make one, but it's not a standard size. It's a specialty. You have to order it specialty. And that is done in many occasions for certain applications. But we're just talking standard sizes right now. All right, so remember that 601. Now, if you want to know what the 601 fuse is for, really, it's designed to fit in an 800 amp fusible disconnect where you don't want to fuse it at 800. Then the 601 will actually fit in the framework. Okay, so there's certain applications where you might utilize that. All right, so, but it is 601 is still a standard size. All right, now, so the question is, where does it allow me to go from the 27.1 to be able to put it on a 30 amp overcurrent protected device? All right, well, we're going to look at that, and that's going to be in 240.4b. And we refer to this as the next size up rule. So we're going to go look at that. So I'm going to take you to that. So here is 240.4 right here, protection of conductors. That's what we're trying to do. And here's B. Now B says overcurrent devices rated 800 amperes or less. Okay, so there's the first caveat. And obviously we're 30 amps. Okay, we're 27.1 and we want to put it on a 30. Obviously, we have to have a conductor that can at least handle 27.1 amps because that's what our load was. But at the end of the day, I want to know if I can go to the next standard size. Well, let's look what it says. It says the next standard size overcurrent device rating, okay, above the ampacity of the conductor being used, protected, shall be permitted to be used provided all of the following conditions are met. So this is truly saying, okay, well, 27.1, there isn't one available. You got to have a conductor that at least handles the ampacity of 27.1, and we obviously will. But when it comes to the overcurrent, you're saying, okay, well, if you want to put it on a 30, I need something that gets me to a 30. So I got to meet these conditions. Now, the first one, and remember, we're talking about a cooktop. First one says the conductors being protected are not part of a branch circuit supplying more than one receptacle for cord and plug connected portable loads. Okay, it's not. So whether this counter-mounted cooking unit is cord and plug or direct hardwired, at the end of the day, it's usually going to be one receptacle for it, and you follow the manufacturer's instructions on that, or hardwired. Regardless, number one is going to be easy to meet. In our case, running that branch circuit directly to this cooktop. That's easy. Remember, we're trying to meet all these rules to be able to go from the 27.1 up to the 30, okay? Now, the second one is number 2, says the ampacity of the conductor does not correspond with the standard ampere rating of the fuse or circuit breaker. Okay, so general rule there. So it's 27.1, and we would have a conductor that's sized at least 27.1. Granted, it's going to be more than that. But if you look at that 27.1, there isn't an overcurrent device available to protect it at 27.1. So we can go up to the next standard size, just like this says, right? Because there isn't one readily available over standard size. And of course, the last one is just, again, making sure that if you do go to that next size, which just means we're jumping up to that 30, as long as we're not exceeding 800 amps. Okay? So remember, next size up rule, if you're over 800, then the conductors have to be full size based on whatever the overcurrent device is, right? But here we're allowed to jump up to the 30 ampere. Okay, overcurrent protective device. Okay, now don't worry, the conductors will take care of themselves here, but I just wanted to show you that process of being able to do the calculated load of 27.1 after rounding and then putting it on a 30 amp overcurrent protective device. Now, conductor sizes. Since we know the overcurrent protected device is 30 amps, the next thing we have to remember is small conductor rules. Now, still got to serve our amps, so we need to go to the ampacity table, 31016. Now, if you're in the 2017 code, it's 31015B16, but we're well beyond that, so we're in table 31016, and that's the same one that was in 2020, same as in 2023. It's still 31016 for ampacity. So let's go there real quick. And we have a 30 amp overcurrent device, but we definitely have a 27.1 amp rated calculated load of that. So we need to make sure what we're doing here. So let's go over here, and I will get us to 31016. And let's see, right here. All right, so in 31016, we're looking at it here, and it's obviously got 3 columns. But we have to remember our question here, and in terminal values or terminal limitations and temperature limitations and all those type of things. So under 110.14c1, only value here is if it's 1 gauge or smaller, or it's 100 amps or less, and I have no other values. I don't know what the lugs are, terminal rating. I don't know what the end attachment plug or device receptacle. I don't know what its ratings is. What I do know is that the ampacity is less than 100 amps. So I am in the 60-degree column. Okay. Now, if you want to know what would happen if my conductors were rated THHN, let's say, and my terminals were rated at least 75, and my receptacles terminals were at least 75, then you need to stay tuned for one of our videos called Derating Demystified 3.0. And that one's tailored to the 2023 edition. But remember, we have other ones out there over on Fast Track's Tube that are based, it's called Derating Demystified 2.0, and it covers everything in the 2020 code as well as the 2017. But we have an updated version coming out for the 2023 edition, okay? All right, so if we're looking over here at this ampacity, and we know what we need to handle 27.1 amps, and we go over here and we say, well, it looks like since it's over 20, it looks like we need to have a 30. Well, that works out great, right? Because we had a 30 amp overcurrent device, and we had 30 amps. Now over here, you see what size it needs to be, 10 gauge. And you notice it has a little asterisk right here. What's the asterisk mean? Well, the asterisk reminding you of something called small conductor rules. And those small conductor rules are going to apply to general applications within a building. We're not talking about to motors and HVAC equipment. There's some allowances in 240.4 E and G and all that, but we're just talking the basic rules right now. Basic branch circuits that you're going to see in your dwelling. We're not talking about HVAC equipment where it's typical for you to see a nameplate rating that's 50 amp maximum overcurrent protection and minimum circuit size of, say, 12 gauge or 20, and you think, wow, that's a big difference. There's allowances in the code that are very specific to allow you to do that. We're not talking about that right here. We're just talking general branch circuit rules, okay? And the small conductor rules come into play. So here you see this asterisk down here. I'll scroll down right here. And this asterisk is reminding us to go to 240.4D. So we picked a 10 gauge, and we need to make sure that we're going to be protecting that 10 gauge. So let's go to 240 and make sure everything works out. So we'll go to 240.4, and we're going to go down to D. And that is labeled right here. As you can see, small conductor rules. And it says, unless specifically permitted in 240.4 E and G, those are the ones that allow you to do those unique things for HVAC equipment and motors and all that. It's not what we're talking about in this lesson. So we're going to follow the small conductor rule. So we go down and we knew it's a 10 gauge. Here's a 10 gauge. And that 10 gauge, because of the small conductor rules, and remember, we're in 240. So we're talking overcurrent protection here, that it has to be protected at 30 amperes. Well, that's good for us because we already looked up and saw that 27.1 didn't have an overcurrent device. So we were to go up to the next standard size, which is 30. And we looked up the loads, and that 10 gauge has to be protected at 30. So 10 can handle the 27.1, no problem. And it's protected at 30 amps, no problem. So we're good to go. So if you go back to the question, you see that everything is in play, and we looked at all those pieces. You know, the interesting thing about the NEC is you do have to learn that there's so many pieces in play. You have the terminal limitations and temperature limitations of 110.14C1. You have the applications where you have to be very aware of the next size up rule and when you can do that or not. And you have to protect those conductors at their ampacity. So many things that you have to work out, okay? Now, since we did all that, one of the things I wanted to let you know that, remember back when we looked at 220.14b, it says that we could use 220. Now, we did all this math, but I wanted you to see in the code that note 5 gives us this direction. So 220.14b sent us to 220.55, and the note told us how we do all this, and it told us that we use the nameplate. So let's go back in this here, and we'll go back to 220.55. And we kind of go down to the notes, and I want you to be able to see these notes. So right here, note 5, right? Which by the way, was note 4 in the 2020 edition, so keep that in mind. It says right here, I'll read it. It says the branch circuit load for one wall-mounted oven or one counter-mounted cooking unit, a cooktop, okay, says shall be the nameplate rating of the appliance. And that's what we did. We used the 6.5 kW as the nameplate, divided that by 240. That gave us the amps. Didn't correspond. We were looking to go to the next available size, which is 30. Then we said, well, what conductor do we need? We went to 310/16. We needed to have a conductor that can handle the 27.1 amps, which is the actual load we calculated. And we see that it had to be a 10. And then we saw the small conductor rule says that that 10 has to be protected at a 30. Then you're okay. Everything works out, right? So that's how we get that permission to do that. And again, this is 2023. In the 2020, it's note 4 that gives you that. Now, the big difference between 2020 and 2023 is note 4 had all these rules in there, but you had to read one and stop, and then there was a different condition and stop, that type of thing. So the big difference in the 2023 is that now it's broken out. You have a few more notes and a little easier to understand. Okay, so let's come back here, and next thing we'll do is we'll look at wall-mounted oven. Again, essentially the same thing, nothing changes here. All right, so we have a wall-mounted oven, a branch circuit to that. The nameplate is 4 kW at 240 volts, so that's 4,000 watts. Okay, K being kilo. You want to convert, it's 4 times 1,000, it's 4,000. So it's 4,000 watts. Divide that by 240, it's 16.7 amperes. So I know that my amp load is 16.7 amperes. Okay, so now I want to go and see, do I have an overcurrent protective device that matches 16.7? Well, you remember we went earlier, and it doesn't. It goes from 20, it goes from 15 to 20, and then to 25. So in this case, 16.7, we want to use the same rules we did before, right? We want to look at it and say, do we meet all the next size up allowances in 240.4b? If the answer should be the same as it was for the cooktop is yes. So then we're able to say, okay, well, it doesn't correspond, and I can go up to a 20. So that's what we want to do. So we selected a 20. Now we have to make sure that we're okay with that 20. So we went to 240.4b. Next size up rule was okay. We're good at 20. Now, we go just like we did before. You go to 310/16. I need a conductor that can handle 16.7 amperes. So let's go to the code. And remember, this is not a continuous load because it's going to be cycling on and off. It's not going to be at its maximum output for 3 hours or more. That's the definition in Article 100 of a continuous load. That is not what we're going to have here. So let's go to 310/16, and we'll look at the ampacities real quick just to knock it out. Now remember, we are dealing with the 60 degree based on the information that we have. It's 1 gauge and smaller. It is going to be 1 gauge and smaller. It is 100 amps or less. All those rules in 110.14c. And so where we're at right here is, okay, so here's 15 amps. And I need one that's 16.7. So I got to go with the 20. Then you come over here and see that it is 12 gauge and it has the asterisks. Okay, so everything's lining up, making sense. So in that case, we go to the small conductor rules again, which is 240.4d because of that asterisk. And we're not talking about any of those unique specialty circuits. We're talking about a general branch circuit that we're dealing with, right? Normal branch circuits in a dwelling. Not something to a motor, not something to HVAC, which we'll cover in a different video. All right, so now what we're going to do is we're going to go back to, where am I going to go here just to verify? Oh, 240.4d. All right, let me go here, right here, just to verify. Small conductor rules. Here's D, right here. And we're going down, and that was a 12 gauge copper. And there's a 20 amps, okay? So everything lines up. We're able to go to the next standard size. We did that, worked out. Now that it's a 20 amp, and we selected, because of the amps we needed, we selected a 20 amps, and we went over and it was a 12, and 12 had an asterisk. We went to the asterisk. It says that it has to be at least a 20 amp rated overcurrent device, so everything works out for this application. So we go back right here, and that's where we get the 12 gauge, okay? Make sense? So pretty simple to see how we work through each one of these. Now, all this lesson today, folks, was to kind of hammer home how you're sizing branch circuits for cooking units, like a cooktop or an oven, in wall-mounted oven. Now, there are applications where you take a branch circuit and you can supply one cooktop and up to 2 ovens from one branch circuit, and you have what's called tap conductors. And that's a rule that we're going to look at in another video when talking about what you do when you have that situation and how you size the branch circuit and whatnot. And it's, guess what? It's still going to use the same kind of notes that are in 220.55, except it's going to use note 6, which used to be bundled in note 4 in the 2020. See how much nicer the 2023 is going to be? Anyway, folks, if you want to learn more about our program and get some of our videos, you got to go subscribe to fasttrackstube.com. We don't share a lot of videos here on YouTube, but if you want to get our entire collection, and it's well worth the $125 annual subscription, then do me a favor, just go to fasttrackstube.com if you're interested. But again, thanks for watching this video, and hope you learned something about branch circuits to individual cooking units. Till next time, stay safe. God bless.